Hello and welcome once again to another Geometry Basic Concepts video. Last theorem of circles we are going to be discussing today. This is the sixth theorem overall and the third theorem in terms of concepts that can help you find out lengths. So this is probably the simplest theorem in circles. All of us have studied this theorem in school. So this theorem talks about a perpendicular drawn from the center of a circle onto a chord. So to explain the theorem, let me consider a circle with center O, which let's say has got a chord AB. And what happens if I drop a perpendicular from the center of the circle onto the chord AB, and let me call the foot of this perpendicular as C. So let's see what the theorem states. So to prove this theorem, to prove what the theorem states, I'm going to make a couple of constructions. I'm going to join OA and OB. So once I join OA and OB, let me ask you a very simple question, and I know that most of you will be able to give me a very quick answer to this. That what is the relationship between triangles OCA and triangle OBA? If you said that triangle OCA and triangle, OCA and triangle OCB, my bad. If you said immediately that triangle OCA and triangle OCB are congruent to each other, you're 100% correct. How do you know that they're congruent? Because right angle, one angle is equal. OA and OB both are equal because they're the radius of the circle, so radius are always going to be equal. And OC is a common side. So by RHS congruency, these two triangles are going to be 100% congruent to each other. Now, if two triangles are congruent, they are completely identical to each other in all aspects, which means that I can say that length of AC is equal to length of BC. This is what this theorem in circles states. That a perpendicular drawn from the center of a circle onto a chord will bisect the chord. So no matter where the chord is, if from the center you drop a perpendicular onto the chord, the foot of the perpendicular will lie on the midpoint of the chord. And the converse of this theorem is also going to be true, which is that if I join the center of a circle to the midpoint of a chord, then that line segment will be perpendicular to the chord. So perpendicular from the center will bisect the chord. The line segment from the center joining the midpoint of a chord will be perpendicular to the chord. Very basic theorem, but extremely important theorem when it comes to questions based on circles. Thank you.